Hi, hello everyone. Yes, I request everybody over here to watch the previous video for sure before you're going to start this video, because in the previous video of circles I explained you the basics of circles, all the important terms, and also we have proved some theorems, very important theorems. So watch it completely and then only come and start this video so that you will be able to understand very easily all the questions of circles, and most importantly ask the questions in the exam point of view. Done. Let us move to the first question. From a point Q, the length of the tangent to a circle is 24 centimeters and the distance of Q from the center is 25 centimeters. Find the radius of a circle. We know that when a tangent is drawn at a point of contact P and when it is perpendicular, okay, to the line, to the same point of contact, then the angle made by it is 90 degrees. That we already have known and we got proved in the theorem. So if it is 90 degrees, automatically this OPQ, this triangle, will be a right angle triangle. Yes. Yeah. Here triangle OPQ is a right angled triangle. Yes. And angle OPQ is equals to 90 degrees. Done. So if it is a right angle triangle, I can use my Pythagoras theorem. Yes. So by Pythagoras theorem, OQ square is equals to OP square plus PQ square. What is OQ square? 25 square. What is OP? We don't know. What is PQ square? 24 square. So OP square is equals to 25 square minus yes, minus 25 square plus 24 square. So what is 25 square? 625 plus 576. Yes. See, we have to check the signs very carefully because it's very important with the signs while you're bringing into your left hand and right hand side. Yep. OP square, excuse me. Yes, OP square equal to 25 square minus 24 square. Yes, 25 square is here. So I brought this 24 square to the left hand side. So OP square will be equal to 625 minus 576. That is equal to 49. So OP will be equal to root of 49. That is equal to 7. So please be thoroughly prepared with your squares. Okay, from 2 to 30 squares. Okay, it's very important, you have to know, and also learn cubes up to 1 to 20. So it's very important for all your chapters because you can easily write the answers without thinking and wasting your time in thinking. Okay. Yes, here they're asking that a quadrilateral ABCD is drawn to circumscribe a circle as shown in the figure. Prove that AB plus CD is equals to AD plus BC. Done. So AB is this part and CD is this part. So opposite sides. These two opposite sides are equal to these two opposite sides. We have to prove that. And a circle was there inside. Yeah. So we know what you know first, write down. So I know that the lengths of the tangents drawn to an external point are equal. Okay, drawn to an external point or equal. You in the exam, please write it complete sentence. Here I am just writing shortcut. But in the exam point of view, please write the entire line neatly that the length of the tangents drawn from an external point are equal. So what will happen? AP. This AP is there, right? This AP is nothing but AS. See, this is AP. This is the AP and this is AS. AP is a tangent drawn from the point P and AS is a tangent drawn from the point S. These two tangents are equal, right? From the first theorem that we learned. So I'm writing AP is equals to PS, the first one. Similarly, BP is equals to BQ. Same, this point. BP is equals to BQ. Two tangents. This is our second equation. And also CR is equals to CQ. This is a tangent and this is also a tangent for this point. These two tangents. Okay. Now you will tell the fourth one automatically. So RD is equals to DS, or we can write it as dr is equals to ds. This is our fourth equation. So when I add all these 1 plus 2 plus 3 plus 4, so what am I going to get is AP plus BP plus CR plus DR is equals to PS plus BQ plus CQ plus DS. Done? Yes. So what is AP plus BP? See here, AP plus BP is nothing but AB. What is CR? CR plus RD. CR plus RD. DR. So what is this? Nothing but DC is equals to what is PS? Yes. Yes, this is not PS. This is AS. Yes, see here. AP is a tangent. This is AS tangent. See, AS. Yeah. What is AS plus BQ? This is AS and this is BQ. Alright. But no, we can't do this. Can I say DS? Yeah, DS is here. So let me write it together. This AS and DS, I am writing it together because they are on same side. AS plus DS plus BQ plus CQ. I am writing together to avoid confusion. So what is this AS plus DS? Nothing but AD. What is this BQ? BQ plus QC, nothing but BC. Yeah. So AB plus CD is equals to AD plus BC. Directly we have proved. Don't get confused or scared by looking at the figures. There will be nothing here. It will be very easy if you know this tangents theorem by using the only tangent theorem. See how nicely we proved it. Yes. Yeah. Two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. Did you remind about the theorem that we have been discussing in the previous video? Yes. See, almost only the theorems that we learned, the problems will be coming including those only. So please know the theorems, understand the logic behind and the concept behind that. Then you can easily solve this question. Yes. Let me write that. See here, this tangent, this AB will be the tangent to which circle? The smaller circle. Yes. Let me write it down. The tangent AB is perpendicular to the radius at point of contact P. Yes. So now what will happen? Angle OPA is equals to 90 degrees. So in this right angle triangle, OAP, this OAP is right angle triangle and also OPB is right angle triangle. Yes, because the angle is 90 degrees, it will become automatically right angle triangle, right? So whenever a right angle triangle comes, I can use my Pythagoras theorem. By Pythagoras theorem, so what we are going to do? Come on. What is OA? Yes, OA is the hypotenuse here. OA square will be equal to OP square plus OAP square. Yes, then AP square will be equal to what? OA square minus OP square, right? So AP square will be equal to, I know OA is 5, 5 square. I know OP is 3, 3 square. 25 minus 9 will be equal to 16. So AP will be equal to root 16, that is our 4 centimeters. So yes, we got a 4 centimeters, but what they have been asking us, they have been asking us the length of the chord. Yeah, the length of the chord. So perpendicular, yes, perpendicular from the center. OP is what it is doing? It is bisecting, right? It is bisects the chord AB to be the larger circle's chord. Yes or no? Yes. This perpendicular is there, right? From the center OP, it is bisecting the chord AB. Yes, it is bisecting the chord means exactly half it is being divided. It is dividing exactly how bisecting means exactly dividing into half. Okay, so what will happen? The length of the chord AB will be equal to AP plus BP. AP plus BP. AP plus BP. That is equals to 4 plus 4. Bisects means equal parts. So if AP is 4, BP will also be equal to 4. That is equal to 8 centimeters. So the length of the chord AB is what? 8 centimeters. See here, the same question that we have done before. They are just telling us to prove that, they told that it is a parallelogram. Okay, it is a parallelogram. So before that, you have to know what is a parallelogram. So in a parallelogram, what will happen? The opposite sides will be equal. Okay, in a parallelogram, the opposite sides will be equal. You have to know this. If we know the condition only, we can solve it easily. And they are asking that, so a circle has been inscribed and now we have to prove that it is a rhombus. Okay, same thing we are going to know. We know only one thing, one theorem. That one theorem we are going to apply it. That is the length of the tangents are equal when it is drawn from an external point. This one you have to, by heart you have to know it. We have to understand it. Okay, drawn at external point, done. So from this theorem, so I am going to do it again. So see here, AP is equal to AS. The same thing I am going to repeat. This is my first equation. Yes, again BP is equals to BQ. My second equation, again CR is equals to CQ. Third equation, DR is equals to DS. Then fourth equation, and by adding all these four, I will get it as, we already got, no, AB plus CD is equals to DA plus BC. After getting this, now you have to say that since ABCD is a parallelogram, then opposite sides are equal. So AB will be equal to CD and BC will be equal to DA. So just substitute the same terms. AB plus AB will become 2AB and BC plus BC becomes 2BC. So AB equal to BC. Hence the adjacent sides of parallelogram or ABCD are equal. Hence ABCD is a rhombus. You can write like this. Same question, but just they change the terms. Yeah. In the figure, two tangents RQ and RP are drawn from an external point R to the circle with center O. First, first of all, you write the given. Exactly the, excuse me, exactly how they have given in the question. So what they have given, the two tangents RP and RQ are drawn from an external point R to the circle with center O. This is the given part. Okay, that's what exactly, write it down. And then now what we are doing, we are going to join this OP and I'm going to join this OQ. Okay, so you can draw like construction, you can write it as construction as the heading. And what you are going to construct here, you are going to join OP, OQ and OR. Okay, this is what we have done. And now what is happening here when I join this OP will be the perpendicular to the angle, the tangent PR, and this OQ will be the perpendicular to the tangent QR. Yes, then angle PRQ is equals to angle QRO will be equal to 120 degrees divided by 2, that is 60. How did you get this 120 degrees? Come on, think. Yes. So see here, this is 90 degrees. Yeah, this is a right angle triangle. Yeah, and this is 90. And also they have given in the question angle PRQ is equals to 120 degrees. PRQ. So you have to mention the reason why they mention all the three letters. Why don't they mention only angle R? Why they mention PRQ? Because it shows the complete angle. We can also write this PRO. PRO means only this angle will come. But they are telling PRQ. So the entire angle is how much? 120 degrees. Okay, so yeah, and now what am I doing? PRQ, this PRQ, this one will be half of this 120, that is 60 degrees, and this one, angle QRO, this angle will be 60 degrees. 60, 60, total 120. That's what I have done here. Done. And we also know that RQ and RP are the tangents. Are the tangents to the circle. So what? And this OQ and OP are what? Radii. Yeah. So we know this, that the radii are the perpendicular to the tangents. Radii. Yeah. So OQ is perpendicular to QR and OP is perpendicular to PR. So from this right angle triangle, I am taking a triangle OPR. Okay. From the right angle triangle OPR, yeah, from the right angle triangle OPR. So what we are doing is angle PQR. This angle PQR, yeah, this is OPR. Okay, I'm taking the angle O. Yeah, angle POR will be equal to, what will be POR? Come on, you know angle P is 90. You know angle R is 60. Yes, I'm writing here. Angle R you know as 60 degrees and angle P you know as 90 degrees. Now sum of the three angles of a triangle is what? 180 degrees, right? So directly I'm writing it as like this. So angle O plus angle P plus angle R. So I'm just writing a shortcut note. Angle O means complete O. So this is angle ROP. This angle ROP and angle OPR. Okay, and this angle ORP. Okay, all these angles together it makes this triangle. The sum of the three angles will be 180 degrees, right? So from this I am going to take directly as 180 degrees minus of 90 degrees plus 60 degrees. So the answer we get is 30. So angle POR. POR means only this one. 30 degrees. If it is POQ, the entire one will come off. So I got the half of the O as 30 degrees. Okay, done. So now what I have to find out? Actually, we have to prove OR. OR is equals to PR plus RQ. PR plus RQ. Okay, done. Yes. Now similarly, if this is 30 degrees, even this is also a right angle triangle. Even here also R is 60. Here also this is 90. and even this will also become 30 degrees only, right? Similarly, even angle QOR is also equals to 30 degrees. Okay. So to prove that PR plus Q are equal to OR, so I'm thinking what I can do. So yes, we have our trigonometric ratios where uh, we can have opposite sides by adjacent sides. Here we don't want all these angles, we want the sides. So what I'm going to do, I'm going to take the trigonometric ratio cos 60 degrees. Okay, from here cos 60 degrees from R angle. If this is my 60 degrees, that my adjacent side will be PR and my hypotenuse will be OR. Yes, PR by OR. So cos 60 we know as 1 by 2. 1 by 2 equal to PR by OR. Okay, so OR is equals to 2PR. Again from this right angle triangle another triangle. So we will get OR is equals to 2QR. Just from the first equation and second equation, PR 2PR plus, I'm adding it, plus 2QR will be equal to 2OR. So PR plus QR is equals to OR. So just I'm using the trigonometric ratio here to get the sides. Yeah. Prove that the tangent drawn at the midpoint of an arc of a circle is parallel to the chord. So this is the tangent T dash, and we have to prove that this tangent which is drawn, okay, at the midpoint of an arc of a circle is parallel to the chord. This AB is the chord and this is a tangent. This tangent and chord, they are parallel to each other. That's what we have to prove here. Yeah, let us start. So since arc AM is equal, so this arc AM is nothing but arc MB, right? Arc MB. Which is arc here? This is the part. Okay, this is the part AM and this is another arc MB. Okay, so when these two arcs are equal, then automatically the chord AM will be equal to chord MB, right? So in this triangle AMB, so AM is equals to MB, right? And also this angle M is there, angle A is there, right? This angle A and this angle B are also equal because angles corresponding to this equal sides are equal. Angle MAB is equals to angle MBA. Just write down since angles corresponding to the equal sides are equal. You have to mention this. Okay, done. Since this TMT dash is a tangent, so what can we do here? It's a tangent, right? So angle, so angle AMT is equal to this one. Angle AMT, this one, and also angle MMAB, this one. So opposite. So what can we say? Alternate, right? These are the alternate angles. This one. Angle MAB. You have to mention that these both are alternate angles. Done. So see, Here angle AMT and angle MAB are alternate angles, which is possible when it is possible only when AB is parallel to this tangent. Therefore, the tangent drawn is at the midpoint of an arc of a circle is parallel to the chord joining the endpoints of the arc. So this so from this what you have to understand is we have just simple circles is all about just what you know, write it down, what the conditions and theorems that you know, applying them and using them here to prove what is asked in the question. Okay, yeah, this is the most often asked questions for MCQs as well. Let us draw. If the angle between two radii of a circle is 110 degrees, then the angle between the tangents at the ends of the radii. Yeah, first of all draw the radius. And this is my point. Let me draw this as my radius and this is also my radius. Okay. Now touching these 2 points, I am going to draw 2 tangents. This is my one tangent and this is my another tangent. Okay. Done. This is the external point T. Let me take it as PT and this is my center O and this is my Q. Done. So what they are asking, the angle between 2 radii of a circle. This is one radius, this is another radius. The 2 radius between the angle is 110 degrees. Done. Then if I cut it, if I join this O and T, then this angle will become 110 by 2. That is, this angle will become 55 degrees and even this angle will become 55 degrees. And we also know that the radius when it is perpendicular to the tangent, this angle will be 90 degrees. Even this angle will be 90 degrees. So 90 plus 55 how much? 90 plus 55, 145 degrees. And we know the sum of the angles of the three angles of triangle will be 180. 180 minus 145 will become 35 degrees. So this angle is 35, even this angle is also 35. So total angle will become 70 degrees. Yeah, done. So the angle between the tangents is 70 degrees. It's mostly asked about the MCQs, this kind of questions. So yeah, attempt it. Now, other than this, some of the MCQ questions I just wanted to tell you. Mostly they will be asking you the definition of a tangent that already you know, and also they can ask you like uh, for example they can give you like a circle. This is a circle and they might draw, okay, this one. So I just touched it, okay. So the by touching one point, what is PQ and what is this QR and what is this AB. So they might ask you the mention. So AB will be the chord, PQ will be the tangent and QR will be the secant. Yes, done. And also they might ask you the 1 mark questions like if QR is a tangent to a circle with center O at a point P on a circle, if triangle OPQ is isosceles, then angle OQP is what? Okay, so most of the times, just now how we have learned in the previous problem, okay, the same type of questions will be asking. Just believe that length of the tangents is equal when an external point P, when it's touching the external point P. So just assuming that, just knowing that, you can attempt any kind of questions, and some assertions and reasoning questions are also being asked based on circles. Or for example, if assertion is given like length of the tangents are equal, okay, and immediately the reasoning will be like this. The length of the tangents drawn from an external point are equal will be the A1, and the reasoning will be the length of the tangent from an external point will be 8 centimeters. Then the length of the other tangent, okay, other tangent will be also 8 centimeters. So yes, right, why both the tangents have same? Because the length of the tangents are equal. Hence, assertion and reasoning both are true. So these kind of questions also they might ask you. Yeah. So what is the name of the parallelogram subscribing a circle? So just now we did right. It's a rhombus. So all these questions sometimes they might ask you in a shortcut way for the MCQs. So yeah, this is all about the circles. So please do watch multiple times and practice again and again to avoid confusion. It's very simple concepts. Only the diagrams looks like that, but when you start solving, it's really easy. So you can score full marks. Thank you.